Namaskar, welcome to all. So, last discussion we stopped somewhere talking about the triple junction and based on the triple junction what uh, deformation has been taking place in particularly in this area because of the plate movement in different direction. And this area is very well known location and the place which is known as the Dead Sea transform fault actually. So, there is an transform fault which has been formed because of the differential movement of the different plates or the nearby plates with respect to one another. Now, this movement has resulted into the formation of very linear valley, and that is what we call the sea part, and the name is the Dead Sea. And there are many settlements, ancient settlements which flourished along this segment of Dead Sea, and they have resulted into major earthquakes. So, when we are talking about the hazard part, that time we will talk about this. We have couple of ground photographs of this Dead Sea part. Okay. So, there we will talk about that how seismology is been linked with archaeological studies, and then how we do archaeoseismology. So, this again the picture gives an idea about that if you are having the oceanic crust, and that part we have already discussed that the oceanic crust are heavier than the continental crust. So, they will subduct below, and older oceanic crust will be denser as compared to the younger oceanic crust. So, the older one will subduct below the younger oceanic plate. So, as we also discussed that because when the plate moves down deep into the earth's interior, the rocks will start melting, and that will result into the volcanoes. So, this is very clear indication of that where you will see the volcanic eruptions. You will not be able to see the volcanic eruption everywhere unless and until you are having the plate which has been subducting into the interior of earth. So, this is an example of the Andes mountain, how they have developed, and the picture shows, the sketch shows about the Nazca plate subducting below the South American plate. So, this side is the Nazca plate which is an oceanic plate, and this part is your continental plate. So, and you also see that there is a portion between this two plate subduction, where the subduction is taking place with the deeper portion, and that portion of course is a sort of an basin, but that then there will be an so this will be quite deep portion depending on that at what angle this plate is been subducting. So, and then of course, the deposition will be there, the marine deposits will be found here in this basin part, but technically this is like is been termed as trenches. Okay. So, this portion of the portion of between the two plates where the subduction is going on is termed as trench. So, this will be the deeper part in that. So, like 2-3 main points which one should remember is that unless and until, so you are not having any plate which has been subducting, no volcanic eruption will be seen, but if there is a subduction, so we will see a volcanic eruption. So, this setting remains same for all subduction zones, and the area between the two subducting plate is been termed as trench. Okay. And this trench shallower or deeper, it will depend on the angle of your subduction subducting plate. Okay. So, this is the example of the volcanoes, and where the plate is subducting, and this part is like the your cascade volcanic chain actually. Now, coming to the other part which I already mentioned in one of my lecture, that the other locations where you will see the magma coming up is your mid oceanic ridges. So, one we have, that is the subduction zones area, where and that the volcanoes will be on the overriding plate, okay, not on the subducting plate. So, this is another point we should keep in mind. Okay. So, one is the subduction zones, you will see the volcanoes, and that what we call volcanic arc, and mid oceanic centers where you are having the rising magma, okay, which is adding up the. So, this we have learned that this is the new magma is coming up, the fresh magma, and that will keep like adding the new crust. So, that what we call as in constructive plate margins. So, on surface there is the only one place which is where you can see this example of mid Atlantic ridge is your Iceland. Okay. So, in Iceland you see the two divergence of the plate plates and resulting into the but here you do not see a very clear eruption of the magma, but this place again and very active related to the other portion of the mid Atlantic ridge. Now, coming to the part where we see the subduction, and as we have already discussed about that, you will have a volcanic arc on the overriding plate, and the portion between the subducting plate and the overriding plate will be your trench area. Now, there is this definitely the deformation pattern is in compression, and mostly what you see is that the earthquakes again which will occur in this area will be deep, intermediate and shallow. So, earthquakes will occur will take place over here in this area. So, that will be a like in deeper earthquakes, then intermediate earthquakes and the shallower earthquakes, and numerous narrow trenches thousands of kilometers long, 8 to 10 kilometers deep, are located in Pacific. Okay. So, they are this portion of the like trenches which are the portion between the two subducting plates are quite deep. Okay. And trenches are the deepest part of the ocean floor. So, the topography which has been developed because of this plate tectonics are like beyond our thought process. Okay. So, they are quite deep, and you can see that how deep they are, like almost like 8 to 10 kilometers deep you will come across. Okay. And they are created by subduction, of course. So, example of volcanic arcs, because you will see the formation of the volcanic arc on the overriding plates, that is your continental plates, even on the oceanic plates, okay, which are lighter compared to the older oceanic plates. So, that examples are Alpine chain, Andes mountain, which has been seen between the Nazca plate and the South American plate, and west coast of Mexico. Then you have Cascades, Pacific Northwest of United States. So, the previous example, one of the slide which we were showing, is very much from the Cascadian Pacific Northwest of United States. So, this is the convergence between your oceanic plate and the continental plate. So, further if we move and see that what other deformation you will come across if such tectonic deformation is taking place. Okay. So, you have like the deformation will be quite intense, in particularly in this portion, okay, and that what we call is the formation of wedges. Okay. So, there will be a stacking of faults in this. Okay. So, what you see are these are the major weak boundaries. Okay. So, these are major weak boundaries along which the movement will take place. So, this is in section and this is what you see on surface. Okay. And very similar deformation we see has occurred in Himalayan zone. Okay. So, you have and the portion which is like the plate subducting below the overriding plate, we usually call that as an seismogenic zone, because this zone or the portion of the contact between the two plates will result into or can produce the major earthquakes. So, schematic model of subduction zone, the oceanic plate is on the right. Okay. So, this is your oceanic plate here is being pushed under the continental plate. This is your continental plate. Okay. So, this is your continental plate on the left side. Okay. This subduction motion can trigger large earthquakes within the seismogenic zone, okay, which in return can cause tsunamis also, provided you have water in this area. Okay. So, if ocean is there, then you will see the tsunami, otherwise not. Okay. And definitely there will be no subduction going on if there is no ocean. Okay. Because oceanic plates usually we see the subduction is going on between that. Okay. So, this again and the section which shows about the spreading centers, and then if you are having the two continents which are coming together, then what is going to happen. Okay. So, these are the two continental plates which are colliding. Okay. So, none of them will subduct. So, there are examples of this also on this planet. Okay. Now, coming to the if you look at the topography on Google Earth, this is the picture from Google Earth, and again what we see here, this is your South America, okay, and this is your Nazca plate. So, what I was trying to tell you that the topography, you will come across the topography is very clear. Okay, wherever you see such part. Now, the dark portion over here where I am putting my cursor is your trench, okay, trench portion. So, the trench is between the Nazca plate which is subducting below. So, if I put in sort of a cross section here, then it looks something like this. Okay. So, you have volcanoes here, okay, because this is melting up, and this one is your Nazca plate, oceanic plate, and this is your South American plate, this is your continental plate. So, the darker portion, why? Because of course, this part is an ocean. So, what we see is the your aerial, or we can say the satellite image. Okay. This is basically the taken from the satellite. Okay. So, aerial image we are looking at, and this darker portion indicates that the light does not go deeper and they are not reflected back, it is observed. Okay. So, it shows darker reflections over here, it is not bright, but the shallower part will be brighter, this one is brighter. Okay. So, this is the portion which marks the deeper portion in the ocean resulted because of your subduction. Now, if we see here, this portion is what we were talking about, these are the Andes mountain, and as we have been discussing about that, and we have seen in couple of slides and the schematic diagrams that this portions will have active volcanoes. So, let us see couple of example of this. Okay. So, you have this portion which is this part is the trench area, and then you have this portion is your the snow peaks which you see and the volcanoes over here. Okay. So, if you go a little bit far away from that, okay, because now another question which you may ask is that why we are not getting the volcanoes immediately over here actually, okay, but you see little bit far away inland, away from the ocean or the coastal areas. Okay. Now, again if I take a cross section here, so how it looks like actually. So, if you have this subduction going on here and this portion is like, so where the melt starts, okay, only then that location you will be able to see the volcano coming up. This portion you will not see volcanoes, this portion you will see, and that is the reason why you are looking at little bit away from the like in kilometers it will be definitely much more. So, this configuration of the subducting plate will also will be responsible and will result into the location or will allow the volcanoes develop away from the zone. So, this is an example of the active volcanoes in that area. These are all pictures from Google Earth, you can see in 3D and try to understand what the formation can do. This is the ground photograph of the active volcano, that is in Osorno. And this volcano, as I told that if the configuration remains the same, the oceanic plate is subducting below, getting melted, and then you are having the volcanoes on the surface. Okay. So, this volcano in terms of its morphology, it is very much similar to the Mount Fuji, which is another active volcano in Japan. Okay. So, this is a Mount Fuji. So, they have this the clear comparison of this two volcanoes. Okay. Now, another part which so far what we have been discussing about that, okay, there is the spreading centers you have, and this spreading centers are the places of constructive plate boundaries. Okay. And then you have the oceanic plate subducting below the oceanic plates, again you will have the volcanoes on the overriding plate. Okay. And this portion will be your trench. Okay. So, those things are now clear to all of us. Okay. Now, the plates which I probably in the beginning I mentioned about that, suppose your plate is moving over some hot spot or maybe the rising magma chamber, then that area will also experience or there will be a formation of volcanoes. Okay. And as it moves away from that, so there isn't. So, for example, if you put a plate here, okay, and then you are having a magma source which is coming from below. So, there is a rising of magma here. So, this portion will have volcanoes. Okay. This portion will have volcano, and if it moves away, because all plates are in motion, they have particular velocity and all that. Okay. So, if they move away, then what will happen is that the older one will move further away from this, and this will be sort of a dormant portion. Okay. This will be dormant portion. So, that you may come across on this. So, what we see is that this portion of the volcano will remain active and this will be dormant, or you can say it is inactive. Okay. So, this example was the geologists came across and when they studied the Hawaii volcanic area. Okay. And they were also able to understand that the motion of the plate never remains the same, the direction of the motion of the plate, okay, it never remains the same, it changes over time. Okay. And once if we conceive this idea, that means that in future the deformation pattern may change, okay, because the plate motion will be different and the configuration between the two plates may change, okay, and that is along the plate boundaries. Okay. So, this is the example of Hawaiian archipelago, where you have multiple islands and few islands are dormant, they do not have active volcanic activity, but the island which is known as the big island or something, I will come to that, that is active. Okay. So, what they did was they tried to date the material or the deposits, or you can say the rocks, and then they identified that as you move away from the big island or the active volcano, the island which is having the active volcano, it becomes older actually. Okay. So, let us see that part how it is gone. So, this theory, or of course, it is proved, but initially there was an postulation and then the theory came up and then acceptance based on the evidence and the signatures which they got, and the analysis or the results which they got. Okay. So, how hotspot and absolute motion. Okay. So, that they were able to figure out. So, during 19th century, American geologist J.D. Dana, he wrote, he is one of the renowned worker who wrote books on minerals and all that. Okay. He observed that the age of extinct volcanoes in Hawaii Island chain increases as one gets away or farther from the active volcano on the big island. Okay. Now, there where there is like the location where you have an active volcano, that is big island, earthquake occurs only near that area, but not in the older ones. Okay. So, if you just look at this one, like, so you have there are volcanoes, the volcanic chain is there, and then you have the active volcano which is over here. Okay. That does not mean that it continuously keep erupting, but it erupts periodically, and these are all dormant volcanoes. Okay. So, no activity. So, and the earthquakes are occurring in the area where there is an active volcano. So, this is for example, you say big island, and if you move away from this, then this becomes older. Okay. So, hotspot and absolute theory, further we move in this. So, what they identified was in 1960, Wilson proposed that long lived hotspot lights anchored deep in the mantle beneath Hawaii. Okay. So, he suggested that this is your plate actually, which is moving on the top of your sort of an hotspot. Okay. So, there is a complete pouring of that. So, and there is a plate motion which the direction is something like this. Okay. So, that was been suggested. Okay. And this hot buoyant plume of mantle rock continuously rises from the hot spot, partially melting to form magma at the bottom of the lithosphere. So, magma that feeds Hawaii's active volcanoes. Okay. So, if sea floor moves over the mantle plume on active volcano could remain over the magma source only for about million years. Okay. So, this was another findings which came up. Okay. So, we will stop here and have more discussion on this absolute motion and related, and then what is the role of the hotspot and how they identified the ages, and how they identified also that how the plate has changed its direction. So, I will stop here. Thank you so much. Namaskar.